simultaneous linear differential equations with constant coefficients. Now we know what are simultaneous linear equations, right? Something like this: 3x plus 2y is equal to, let's say, 5, and say 5x plus 7y is equal to 3. Yes. Now how do we solve these type of problems? What we do is we multiply both the equations with something which enables us to cancel one of these variables, right? So for example, we may multiply this by 5 and multiply this by 3. So if we do that, we get 3 5 is 15x plus 10y is equal to 25. 15x plus 21y is equal to 9. Now we subtract. So these two get cancelled out. Minus 11y is equal to 25 minus 9, 16. So y is equal to minus 16 by 11. And then what do? Then we substitute this y into any one of these two equations. Yes. So we say 3x plus 2 times minus 16 by 11 is equal to 5. 3x minus 32 by 11 equal to 5. 33x minus 32 is equal to 55. 33x is equal to 55 plus 32, which is 87. So x is equal to 87 by 33. So the solution is x comma y, which is 87 by 33 comma minus 16 by 11. Okay, so something similar to that with respect to differential equations. So let's actually see how to do that. Let's say x and y are functions of t. So dx by dt plus 7x minus y is equal to 0. This is one equation. Plus 2x plus 5y is equal to 0. So again we have to multiply or operate, as we call it, the equations with something in such a way that one of these x or y cancels out, right? So what shall we do? First of all, let's write it in d notation. So in d notation, this becomes d plus 7. This is dx by dt. So d plus 7x minus y is equal to 0. And here what will happen? 2x minus plus d plus 5y equal to 0. Let's write z equal to 0 together. Now we know what to multiply, right? Let's multiply the above one, the first equation, by d plus 5, and the second one, nothing, we don't have to multiply it with anything. So what will happen? This will become d plus 7 d plus 5 x minus d plus 5 y is equal to 0. And the second equation remains plus d plus 5 y is equal to 0. And now if you notice, these two get cancelled out and we are left with d plus 7 d plus 5 x plus 2x is equal to 0. Let's open up these brackets. D square plus 5d plus 7d plus 35 x plus 2x equal to 0. d square plus 12d plus 35x plus 2x, 37x equal to 0. This is within brackets. Okay. Now this is a form which we are familiar with, right? Okay, so which means we know how to solve this. Auxiliary equation m square plus 12m plus 37 equal to 0. M is equal to minus 12 plus or minus square root of b square 144 minus b square minus 4ac, 37 times 4, 7 4 28, 2 3 4 12, 40, 148 divided by 2a, that is 2. So m is equal to minus 6 plus or minus 148 minus 144 is 4, so 2, but because of minus it is 2i divided by 2, so which means minus 6 plus or minus I. Conjugate complex number, so our complementary function is c1 cos t plus c2 sin t e to the power of minus 6t. That is the complementary function. Now, I was using m because that is how we were doing it in our previous sessions. We were writing the auxiliary equation in terms of m. But if you think about it, this is nothing but x is equal to c1 cos t plus c2 sin t e to the power of minus 6t. Yes. So one part of the solution we have. Now, by the way, you might be wondering about particular integral. Now, remember that becomes applicable only when the right hand side has something other than 0. Now, here the right hand side is 0. Okay, so x we have got. Now, we have to figure out y. Now, y we can get by substituting x to the any one of these two equations, right? So we know we will require dx by dt, right? So let's first figure out that d of x is equal to d by dt of c1 cos t plus c2 sin t e to the power of minus 60, right? So now we have to apply the product rule. We can directly apply the product rule, or what we can do is split this into 2 and then do it. Okay, so let's do it without splitting it. Let's differentiate this term first. Okay, so cos t is minus sin t, so minus c1 sin t, sin t is cos t, so plus c2 cos t, and e to the power of minus 60 remains as it is. Now we differentiate this. So when we differentiate it, minus 6 e to the power of minus 60, and this remains as it is, c1 cos t plus c2 sin t. Take one of the equations, dx plus 7x minus y is equal to 0. Remember, this can be written as y is equal to dx plus 7x. Yes, so that is how we get the value of y. Now dx we have just evaluated it, so minus c1 sin t plus c2 cos t e to the power of minus 60 minus 6 e to the power of minus 60 times c1 cos t plus c2 sin t plus 7 times x. Yes, and x is c1 cos t plus c2 sin t. c1 cos t plus c2 sin t e to the power of minus 6t. Now let's simplify this. Yes, okay. So c2 cos t e to the power of minus 6t minus c1 sin t e to the power of minus 6t minus c1 cos t e to the power of 6 is also there, minus 6t minus 6 c2 sin t e to the power of minus 6t plus 7 c1 cos t e to the power of minus 6t plus 7 c2 sin t e to the power of minus 6t. Actually, I could have taken the whole e to the power of minus 6t as common out. Okay. Actually, let's do that. What we can do is to remove it from here itself. Let's take the whole thing inside a bracket and say e to the power of 6t. Yes. Okay. Now cos t, cos t, cos t. Yes. Sin t, sin t, sin t. So let's group them together. c2 cos t. This is sin t, sin. This is c1, c1. So we can actually do the simplification. 7 c1 cos t minus 6 c1 cos t is c1 cos t. Okay. Then minus this again is plus. So plus c2 sin t minus c1 sin t e to the power of minus 6t. Okay, again we can, here there is a plus. Okay, so c1 plus c2 cos t plus, or if you want it as c1 c2, then minus c1 minus c2 sin t e to the power of minus 6t. And remember, this is y is equal to. So our solution is x comma y. So we have the x here. So let's write it once more. X is equal to c1 cos t plus c2 sin t e to the power of minus 6t. And y is equal to c1 plus c2 cos t minus c1 minus c2 sin t e to the power of minus 6t. Now this was when the RHS was 0. Now let's do one more problem when the right hand side has some other function. Okay, let's do the second problem. Let's say we have d square x minus 3x minus y is equal to e to the power of t, and we have dy minus 2x equal to 0. Okay, remember here both x and y are functions of t. So, and d is not dy by dx, it is d by dt. Okay, so let's, now how do we solve this? Here you have a dy and here we have a y. So if you multiply this by d, we get to cancel these two. So let's multiply this equation by d. Now remember, here x is common, so we can write it as dx square minus 3x. But now we are multiplying it with d, so dx minus dy is equal to det. Now let's write this equation. So plus dy minus 2x is equal to 0. Now we add these two, it get cancelled. and we are left with d square minus 3 dx minus 2x equal to det, right? Now this can be written as d cube x minus 3 dx minus 2x equal to det. Now remember, this is something that we are already familiar with. Yes, so we can solve this for x. So first we figure out the auxiliary equation. M cube minus 3m minus 2 of x is equal to this, but in case of auxiliary equation is equal to 0. Okay, now let's simplify this. Now how do we factorize this? Rather, let's put 1 cube minus 3 minus 2. No, let's say 2 cube is 8, minus 6 minus 2 is minus 8, so 8 minus 8 is 0. So which means m equal to 2 is a root, right? So how do we get the other factors? Let's divide m cube minus 3m minus 2 and divide it by m minus 2. So m square m cube minus 2m square minus plus these two get cancelled, 2m square comes as it is and we bring down 3m. Now plus 2m, so 2m square minus 4m, subtract these two cancels, m minus 2, so plus 1 m minus 2 0. So which means m cube minus 3m minus 2 can be written as m minus 2 times m square plus 2m plus 1 equal to 0. Now let's factorize this as well, or rather let's find the roots. For that we need to factorize this again. So this is nothing but m plus 1 square, m square 2m plus 1 square 1, which means m is equal to 2 minus 1 minus 1. So we have repeated roots. So our solution is, or rather complementary function is c1 plus c2t e to the power of minus, yes, minus this t comes from this repeated roots, minus t plus c3 e to the power of 2t. Okay, so this is our complementary function. Now let's figure out the particular integral, because the right hand side is not 0. So 1 by d cube minus 3d minus 2, d cube minus 3d minus 2 times the right hand side, which is e to the power of t. Okay, now d is what? D is going to be 1. So let's do the substitution. 1 cube minus 3 minus 2 e to the power of t, which is equal to 1 by 1 minus 5, that is minus 4 e to the power of t, which means it is 1 by 4 e to the power of t. So our solution is, that is x is equal to c1 plus c2t e to the power of minus t plus c3 e to the power of 2t minus 1 by 4 e to the power of t. So this is CF and this is PI, right? Now we have got the x. Now we have to figure out y. So let's take the simpler equation, that is dy minus 2x equal to 0. So dy is equal to 2x, right? So which means 2 times c1 plus c2t e to the power of minus t plus minus t, c3 e to the power of 2t minus 1 by 4 e to the power of t. Okay, now we can bring this d down. Now what we can do is take 2 out and integrate. This becomes 1 by d, right? 1 by d of this. So which means we can integrate. If we integrate, this d disappears. So let's do the integration. Think of it like this. Because there are 2 parts, we would have done product rule, right? So we have to go reverse. So minus c1 plus c2t e to the power of minus t. Now if we differentiate this, what do we get? This becomes minus into minus plus c1 plus c2t e to the power of minus t, right? So which is what we have, but we would have differentiated this as well, right? And this would have kept as it is, right? So e to the power of t minus t would have been as it is. If we differentiated, this minus comes down, so this should become plus here, so minus again, and differentiation of this would have given us c2. Now if you differentiate, you will get back this, okay, plus c3 e to the power of 2t. Now if we differentiate this, we get 2 e to the power of 2t, so we divide it by 2. Okay, what about this? This remains 1 by 4 e to the power of t. Okay, so we have integrated this. Now y is equal to minus, let's take it out, c1 plus c2 t e to the power of minus t minus c2 e to the power of minus t plus c3 e to t by t minus 1 by 4 e to the power of t. By the way, this becomes plus because we have taken minus out, and this becomes minus and this becomes plus. And x is equal to what? X is equal to c1 plus c2t e to the power of minus t plus c3 e to the power of 2t minus 1 by 4 e to the power of t. So this is the solution. Okay, so here I kept it simple so that I had to multiply only one of the equations, right, with something else. So in general, if d is equal to d by dt, then f of dx plus f2 of d of y is equal to some function of t. And we have another equation with g1 of d of x plus g2 of d of y is equal to some other function of t. Yes, so here f1, f2, g1 and g2 are functions of d with constant coefficients, and these two are functions of t. So basically use elimination method. Take care of elimination method. We might have to multiply both the equations with something which provides us some commonality which can be cancelled out. The idea is to arrive at x is equal to f of t and g of y is equal to g of t. Yes, and we have seen how to do that. I think that's enough for today. Bye for now.